Hi guys, welcome to this second video on the tutorial series. What we are going to cover is agent design patterns. Now, if you ask ChatGPT what agent design pattern is and why ChatGPT, because I don't know if anyone uses Google, at least people that I know, they don't. So these days, we have all these AI-based interfaces. Even Google has its own. So when you are doing Google search, so it's using the AI model besides. So overall, if you Google this term or if you ask ChatGPT, agent design pattern, you will find something like tool usage pattern, reflection pattern, something like that. But we have seen in our previous video that there are so many features that could be part of an agent framework. One of them was observability. One of them was orchestration. So should I call orchestration as a agent design pattern? Because if tool usage is a pattern, then orchestration is also a pattern. It's one of those features. So I'm not going to call the features provided in a framework, or even if there is a custom code and there are certain libraries in that code base, I'm not going to call them as design patterns. Now, the idea of design patterns is it goes to software engineering design pattern, where we have this factory pattern, singleton pattern. It's quite interesting actually. There are different type of ways you can structure your code. So in that sense, actually tool calling, observability, orchestration, they could be design patterns. On another hand, we have these architectures where we have these moving pieces, high level design, specifically talking about system design. So we have this high level architectures, memory management, then how do we do deployment of the servers? We may be using containers, but do we deploy that in a Kubernetes cluster, or do we use something cloud provided like ECS Fargate? So we have these design patterns in software engineering, which talks about abstraction. Then we have this system design, which talks about architecture. These are two fundamental blocks of software engineering. What I'm going to propose here is an abstract way to define how do we put all these agents together. I'm not going to go in direction where we have this code driven design patterns. That's why I'm never going to call tool usage as a design pattern, even though you would have seen or you might see that there are many authors. I'm not going to name them, but there are very reputed and established authors, like big guys. They call tool usage as a design pattern. Then by that definition, all the features that we have in agent framework, so all of them could be design pattern. So I'm not going to do that. So I'm sort of redefining what a design pattern should be. It's nothing but how we are going to use these agents. Are we going to use one agent or more agent? Later on, I will talk about workflows. So are we going to use one workflow or multiple workflows? Or there is some hybrid combination. So based on that, I'm going to define the design patterns. So I just wanted to clear these things up because you will go out there and then you will search for what are design patterns, then you will get confused. So I wanted to have all these things sort of concretely defined to begin with. Let's talk about our first pattern. It is single agents. Now, I mentioned in the previous video that there are so many open-ended pool of questions like what is AGI, artificial general intelligence, and a similar or more profound concept would be ASI, artificial superintelligence. It's supposed to be the collective intelligence or even superior than the collective intelligence of the entire human race. So before we get there, in maybe let's say tomorrow or in 100 years, what we have is agents. Now it is very powerful. What we have these days is very powerful language models where we do not have to do a whole lot of prompt engineering. Gone are those days. Just having a small and precise prompt can get the job done. What's important is context engineering. How do you give the right context so that the LLM can understand? And what you have is a very small, well-defined prompt. So think of it like a first principles. If you do not know what that is, look for it. Understand what first principles are. But quickly, first principles are the smallest units of reasoning that you want to put, or facts, or truth. So it comes from philosophy. So in that, the smallest unit of truth is called first principle. So putting that here, well, taking an inspiration from first principles and putting that into agent's perspective. So what you have is smallest unit of reasoning. That is your prompt. Okay. It's very simple definition. What is a prompt in terms of how we have these very capable language models is a well-defined a unit of reasoning. That is a prompt. So you have the context, you have your prompt, and then you can ask the LLM to do a certain thing. So if we have is a unit of objective, a small objective, then we are going to use single agents. Now, for example, we want to check the flight price. So of course, the language model is a static one. It's not going to go out there and make an API call and fetch the flight for you, but it can understand. Even before it does the fetching, it takes a natural language input, the one that you are going to ask it, and then it's going to call a tool and then fetch the flight information and then respond to you. So it's a very sort of a unit of work that it is doing, and it can do without taking help from other agents, or there is no need for a complex workflow. So that's where you use single agents. This is first design pattern. Second is workflows, where you have predefined rules, step by step, what you want to do. For example, there is an approval process. Maybe you want to give a virtual machine to someone, so there has to be an approval process for that. You can use workflows there. Multi-agent as workflow. Now, this is interesting. In real world, we often have different agents. We have a bigger task, and to achieve that task, we want to go from slices of reasoning, from one reasoning to another. And there would be context at each stage as well. So we are looking at a multi-stage reasoning sort of to achieve a certain task. The task is so complex, and that's why we need multi-stage reasoning. There could be branching as well. So one reasoning, and then there is a context, it produces an output. It could be input for several other reasoning units. Now, you would have noticed that I'm using reasoning instead of agents. So they are, think of them as synonyms. So agent is a collection of, or sort of a, it's a collective unit of a context, a reasoning unit, or a prompt, and then you have your tools and so many other things. But these are the primary ones. And tool gives it the context. So if you have a complex workflow where you have sort of non-deterministic input and output going on in between the stages throughout the workflow, that's where you use multi-agent. So you have a bigger task and you want to break that into small units of reasoning. Now, these are just theoretical for now, but I will give you a comprehensive walkthrough of code when we come across these things. This is going to be a comprehensive course, I have promised. And I want to clear the theory first before we dive into code. Last one is multi-workflow. Now, this is a complicated one. If we have very complex workflow, for example, data analytics, data science bots, so they would be having so many things. For example, the data science one, it would have domain understanding, and it would have data preparation, and then pre-processing, then feature engineering, then training the model, then evaluating the model, so many things. Now, each of them could be a workflow on its own. So, a workflow of workflows. You can have multi workflows. So, this is how I am defining the agent design patterns. And this is a, so let's say the universe of agents. So, this is multi workflow is sort of a superset, the universe where every other workflow or other agents they are part of it. So this is how I'm defining the agent design patterns. Let's have quick recap before we dive into today's code. We have single agents, we have workflows, multi agents as workflows, as workflow, and then multi workflow. Now this is my definition, and when you are using that, using all this in your job, remember that this is not something standardized. This is how I am defining things. And if you are taking any interviews, you this if you say these things, it will just confuse the other person because the other person will be learning from Google, or he would be reading some textbook. I don't know. But this is how I am defining it. This is how I find useful for my work and use this for projects. And for interviews, you have to prepare for them separately. So with that, let's dive into some code. Okay, so what I have here is, now you had seen yesterday's code. Now this is a comprehensive one. What I'm going to do eventually as we progress through the course is going to cover all those design patterns and all the features of the agent framework, tools, orchestration, observability, and whatnot. So I thought that what is the de facto user interface for Agentic AI? It's a chatbot. So let's build one. So I have built this chatbot for us so that we can navigate through the course very smoothly. And I will breeze through the code setup folder structure today in this video. And from the next video onwards, I'll be changing things wherever I feel the need to be, so that you will be able to relate. So this is your boilerplate project. What we have here is, at very high level, we have three folders. One is API, and then core, and then UI. I have also installed Streamlit, which is inside the requirements.txt. And please make sure you have that installed in addition to Agent Framework. I have provided the README instructions here so that you will be able to run the agent and server as well as the UI. So as I mentioned, we have three folders. So we have three commands as well. We will first look at the core folder where we have our agents and those things defined. So the main.py of yesterday is now called run.py, and I have done some abstractions here. Now you would be familiar with these, the responses client and then the agent, and then we run it here. Actually, this piece, it should be outside, and then it doesn't need to, because every time I'm calling this function, I'm creating this client. So I will refactor that in the next video. I just noticed that it's there. So what we are doing is we have this abstraction and it's going to create the client and then run that agent. Now, here is the interesting part. Suppose I ask it a question and then after I have that answer, I ask a follow-up question. You see, I'm asking it to add things and then there is a follow-up. So which means the agent has to remember what I had asked before. How it's going to do that? It's going to need memory. And that's where this piece comes. We are using this in-memory store for now. Now in production, you would have Redis, and then if you want to go for third party, there are different services in the documentation. I think it's called mem0 or memo something. But since my audience, what I'm thinking is the enterprise developers who are working for enterprise and they will be using Azure services. So I want to keep this tutorial lightweight. So I'm not going to go for creating an Azure service like Redis and then use it here. Even though I'm using the framework and the language model deployment is in Azure, but I've decided that I will use chat message store, which is the library provided one, and I will just create a global variable for now. Maybe when we talk about production deployment in future, I will swap that with Redis. I'm not going to go for Memo or Mem0, that third-party storage provider, because in an enterprise environment, our data is private, even though Microsoft has all our data. And if you see, if you have created the LLM endpoint, they will tell you actually. But it's debatable. At least, I don't know. If you are an enterprise customer, then you would know better than me. So I will keep this in memory storage. And what this does is it gives us a message store per session. Why we need per session? Because we also have, this is our core and we have the session ID. So we want to retain the history of the previous messages per user. So for now, just think about that this is a mechanism to remember the history. And this is what we see. Our core, if I run it, the first response I get is 7, and then I get 17 because I just added 10 to that. Excellent. Now, this is fine. What we are going to do is to create an endpoint out of it. So I'm using Fast API, which comes bundled with this agent framework package. Actually, agent framework deployment talks about how to use Fast API for the deployment. But I think what the documentation says, at least for now, what it says, it's still in development. And I do not want to touch upon too much of experimental features for now. So what I'm going to do is to just use the Fast API in a regular fashion. So here is the Fast API implementation of the routes, and here is our chat endpoint. What I'm doing here is I've kept the code very lightweight, and I'm using Pydantic model here to receive the message and the session. And I'm just going to call the agent, the call agent function, which is over here. Now, when that request arrives, so we are going to hit this function, which is over here. If it is not there, so we have this new session ID, and then we just assign that session ID to a new chat store. Okay, so this is fine. But even before we have that, who is creating that session ID? So let's talk about that. I have another endpoint here, which is used to create the session ID. So which means if I have a client who calls this endpoint, they should have the session ID. And then in the consequent request, when I'm hitting this chat endpoint, I can pass that session ID. Let's see who that client is. So all our API work is done here. Our core is also done here. The only piece we have left is the UI. So we have a Streamlit app. And by the way, I'm not a code wizard. This is all vibe coded output. But of course, I have seen every line, what it does. So it's fine. I can trust this code. So when we have this app initialized, this Streamlit app, and by the way, how do you run that fast API? Did I mention? So this is how you run that fast API endpoint. You have that folder name, and then the file name, and then the object. Okay. So here is our Streamlit app. We have our chat input, and then we want to show what the user has typed. That's fine. And then we want to go for processing. Here we are making the API call to the chat endpoint, and we have defined our endpoint over here. And once we have the response, which means we are going to hit here, then we are going to hit there, and then we are going to go for call agent. There is a shortcut. If you put control and click, you will directly go to that function. And we have here, and then we are going to do our session management here, and then call the run agent. And because this is async, so we have to do await and then return. And then we have our response received here. This is fine. And then we are just outputting that response here once we have that response object. And we have the response object as string. Okay. In addition, what we are doing is we are keeping track of all the messages here as well. So we have the messages being stored in the backend as well as the front end. Later on, we will have a centralized store, and instead of Streamlit, we might have Next.js endpoint. So when that happens, I will walk you through that as well. So let's see this app in action. I have the endpoints running, all fine, and this is how our app looks. So when I do the refresh, we have this session ID. I have truncated that. So here it says AF79. And if I refresh, I should see a new session ID. So this is C28. Okay, let's test this. So I will go to this core to copy the example that we have. What is x plus y? X is capital here. I do not like inconsistency, but it's fine for the demo. So we have 7 here, and I'm going to ask add 10 to that. Let's see if it remembers the history, because this is one of the problem. If you are asking something to the chatbot and after 5 minutes it has forgotten what you had just asked, then that's weird. So it remembers the chat history. Fantastic. So what we have covered here today is memory. Now let's go back to our slide. So this I have highlighted while preparing this demo. We just covered the memory. Now for agents, this is fine. But for workflows, the memory management is going to be slightly different. We'll see how it goes at that time. So if you have made this far, I thank you. And I hope you had learned a thing or two, especially the agent design pattern, how I have defined. It could be very different from how you would have heard or you might learn in future. Now this will help you how to structure the project, because it takes just so much time when you are in a real project and you have to design how many agents you need, how you are going to do the orchestration. So hope this video will help you. And I will push all this code in the GitHub. You will find in the description section, and download and ask your questions in the comment section. And I will see you in the next video. Bye.